Welcome to the fifth video for Module 8 of Tech 206. We're going to discuss some of the finer points of HSM Express CAM software, but keep in mind that in lab we will go through the actual example that we're going to take a look at here. There is a document on Blackboard that you can download that is an HSM Express quick guide. However, it is written for inventors, so some of the pictures and images may not be exactly accurate. But the point is to keep in mind is that HSM Express works the same in both Autodesk Inventor and SolidWorks. So it's pretty similar, so the guide may still be of some help to you. The goals of this lesson is to understand the software interface controls, understand how to create the setup of the part in HSM, defining the tools that you're actually going to cut with. Then we'll talk about face milling, rough milling, contouring, post-processing, and something you'll like for those of you who remember creating by hand the setup sheets as the process plan. This will create those setup sheets for you in HSM Express. So the user interface you'll find in SolidWorks once you've installed the add-on for HSM Express. You'll find a little tab in your ribbon that's called CAM. And if you press on that, you'll see the different features of the ribbon, and we'll go through some of them, but there's Simulate, we're going to work with that, Post-Process, Setup, Sheet, there's the Setup folder here, then there's the options for drilling, 2D Adaptive, 2D Pocket, Contouring, Facing, Slotting, Tracing, Thread, Circular, Bore. There's the tool library. So we'll look at some of those in this video. So here's the basics of some of these controls and interfaces. Simulate runs the toolpath selected. Now, if you haven't created any toolpaths yet, there's nothing to simulate. Post-process converts the toolpaths to actual CNC code, so you do this at the very end. Setup sheet will generate a setup sheet based on the current setup, and you can get it in different formats like HTML or Excel and so forth. Generate regenerates the operation when the model has been modified. Setup defines the properties of the part to be machined, so you typically do this first. Folder allows the creation of folders to group operations, so if you have a really long program, you might want to use folders. Drill generates a drilling path. Keep in mind that tapping and boring are also within the drilling cycle and selection here. 2D Adaptive creates paths for external or internal rough milling. 2D Pocket creates the final tool paths for internal finish milling. And 2D Contour creates the tool paths for external finish milling. The one interesting thing is that in the adaptive tool path, there is no way, at least in previous versions of HSM Express, to turn on cutter comp in the controller for adaptive, for roughing. However, you can turn it on for finishing in the pocket and contour commands. Facing, or face, creates a tool path across the face of the part, and slot creates the tool path for general slot. And you can also do that with a 2D pocket as well. Trace creates a tool path along the contour with variations in the Z-axis. We'll do that in a future lesson. Thread creates the tool paths for thread milling. Circular creates the pocket of or a hub, as the case may be, for an internal or external feature of size. Bore creates toolpaths for bore milling. Okay, that's not quite the same as the boring application as part of drilling. Orientation provides various options for viewing the machining of the part. You can actually see a sort of live simulation of the machining. Tool library displays the internal library for viewing or editing. Task manager allows viewing of tool paths that are running in the background. CAM options lets you change the options. Setup. On the CAM ribbon, click Job Setup, or rather Job Panel Setup. The Setup Operation dialog is displayed with the Model tab active. So you have Model Orientation, Stock Box Point, and the bounding box point that's here. So it basically tells you where you want the outside of the stock to be. and how you want X, Y, and Z oriented in relation to that. So what I recommend is that on the first tab of the setup box, select the Z-axis plane and X-axis option. Then use the WCS Z-axis button and select an edge parallel with the desired Z-axis. So that'll set your Z. Then use the WCX X-axis button and select an edge parallel to you want the X-axis to be. And then flip them for plus and minus as desired. And then under the PRZ, under origin, that's where you set the PRZ rather, set the drop-down menu to select a point, and then use the WCS origin and select a desired origin point on the part. So in this example that we're going to do in lab, I actually select the center point as XYZ, and notice how I have the axis oriented, and then it's pointing this way. It means X is plus in this direction, Z is plus in that direction, Y is plus in that direction, which is your typical lathe, or excuse me, your typical mill setup. Now go to the second tab on the setup menu and select the stock tab. And this basically says, do we want extra stock to show on the top and side and model? And it says that because our model includes the base portion of the stock, we can simply set it all to 0. But there will be times, especially where we want to set the top offset to a little bit more if we have a thicker stock, as the case may be. Go to the second tab on the menu, and that's the stock tab. Here we can set additional stock to the projected stock beyond what was defaulted by the program. This is already actually set the top stock at 0.1. We assume there's more to take off the top when we're going to mill the face mill across the top of that. The third tab is the Postprocess tab. This tab can be used to change the program settings or to add multiple workship locations, but for now, in the beginning, we just leave this and hit OK. To do facing, you select and specify a face mill to mill the top of the stock to Z0. You basically press the face button that's highlighted over here, and then that will bring up the facing menu. And the first thing you do is you select a tool to face with, and you can go and you can search for face mills, and you'll see some options. There's a 2-inch face mill. You can select that one, hit the select button. Now you go to the next tab, after you selected the tool, staying on the first tab, you select the speed parameters and other similar cutting rate parameters. The second tab allows you to select the stock, but this has already been default selected for us. Third tab allows us to set the retract heights. Start with the defaults for now. We can change them later. The fourth tab allows you to program multiple passes, but again, in this example, we just do one. The fifth tab allows us to set lead and lead out, and we'll start with the defaults. If you press OK, now you can press the simulate button and watch it cut. Now, when we do this in lab, you're going to see that the face mill retracts up while still engaged on the surface of the part. We want it to extend further out. So if we do that, we want to first close the simulation, then right-click on the face feature in our browser, and you can edit it. And then on the fourth tab, you can set the passes to pass extension to 1.5 inches and click OK. And if you rerun the simulation, you will see that the face mill comes out farther past the edge of the part. 2D adaptive, to rough contour the geometry of the part, select 2D adaptive option from the cam ribbon. As we did in the face mill example, press the tool button, locate and select a 1/4 inch flat end mill, and then set the parameters set here on the screen. On the geometry tab, uncheck the machine cavities and leave the stock contours set as default. When I first started doing this, I couldn't figure out why it wasn't cutting right, and this little box was default to being checked, and that would imply that it's an internal part. It's a cavity. Press the select option next to pocket selections and select contour of the model. And so you want to select this portion down here. It says don't forget to click the plus sign after selecting your contour, or the software will not remember your selection. Check your heights on the third tab. The default should be acceptable. On the fourth tab, under passes, select the multiple passes, or rather multiple depth option, and select the maximum roughing step down to 2.25 inches, and press OK. Then press simulate, and you'll see that it cuts around the part in depths of 0.25, and then it steps down for the next depth. Now contour, this is your finishing of the outside of the part. Select the 2D contour option. The software defaults to the 1/4" end mill we just used. However, you typically want to have a different tool for roughing and finishing to account for wear. So go back to the tool menu, select the 1/4" end mill again, and now you'll have another 1/4" end mill show up as tool number 3. Set the parameters as shown on the screen here. Select the part contour as you did for the 2D adaptive option. All other options can stay the same. Select OK, and you can run the simulation and watch the end mill do a finish pass around the part. Finally, you can post-process to get the actual code. You press the post-process option on the cam ribbon. Select the emc.cps post-processor and click post. So that's this selector here. Remember, it'll be a different one for your homework, which you'll select a HOS option from here. But select the post-process button here, and then it'll actually create the G codes, M codes, as you see in the example here, and then you just save that file to a convenient location. Once the post-processing is complete, that's when the NC editor actually opens and you can see the codes. That's your program. And that's what you're going to demonstrate for me in the homework in lab. There's no need to upload this or anything like that. Setup sheets. To get an editable setup sheet, the best method is to use the postprocessor command. You select postprocess again from the cam ribbon. Now for postprocessor type, you select Setup Sheet Excel 2007. That's this one right here. Select Post and save the file. And then Excel will open up and show you your setup sheet. And check all the tabs in Excel for all the information. And that is it. And thank you for watching Module 8 for Tech 206.